The Enterprise Information System for Peer Production, or EISPP, was a series of wireframe animations that I came up with in the spring of 2015. The thread of thought that led to it was inspired by people on an internet forum who were building open-source fusion reactors, those in the hackerspace movement, and feelings about apparent restrictions that higher education to employment pipelines place. EISPP asked the question, how do I match my creativity to the needs of others in a world without feeling like there are 20 a made-up number, different majors to choose from. The college major categories that have existed for decades, as well as the well-trodden career pathways that may not be a perfect match for what an individual has to offer, and in some cases, the individuals may feel straitjacketed into a culturally accepted expression in order to get a paycheck. Hobbyists have, for many years, worked together to share what they have learned with each other to advance their knowledge. This phenomenon has continued on the internet. One might argue that a large fraction of innovation has come from passionate individuals that bear the title amateur only to have their passion codified in some formal structure later. Creativity seems to thrive in environments where there are a few barriers to free association of ideas and their implementation. However, job websites and universities seem to be rigid. One struggles to map themselves to these systems. Although it may have been efficient to organize systems that provided useful services in a hierarchical way, technology could allow for stigmergic collaboration. One could argue that the internet has allowed for this self-organizing behavior, which seems to be like the evolution of thought in the learning process. However, there still appears to be a lot of friction. EISPP proposes a graph-based system and displays research that makes it more amenable for a participant. It is a front end to a distributed web of data. Like a web browser, all the data that it can display does not exist in a single place, or within EISPP. It rides on a giant global graph concept envisioned for the semantic web. And in fact, it uses many of the tools developed by the Decentralized Information Group at MIT and those around Sir Berners-Lee, who coined the terms semantic web. EISPP does not address the glacial rebound of culture or individuals that may occur to resist the deployment of such a system. It does not address all of the legal challenges. It does touch on open source hardware and Creative Commons licenses codified in the Resource Description Framework, or RDF. It does touch on possible ways to manage information better that could be later expressed in the cultural and legal arenas. I personally am not a lawyer. I'm not sure what to call these groups. Perhaps virtual companies. This thinking does seem to allow for graph-based organizational models. It is hoped that such thinking will allow for individuals and groups to be more productive and efficient, and through effective information management in the digital world allow for chaos that creativity craves. I hope that EISPP will be seen as a tool, and not as a substitute for inspiration that comes from the subconscious mind, or good fortune that comes by chance, or some sort of divine influence, or everything good that comes from healthy human relationships. At the start or during any other time, one may configure how EISPP works. I can change how data is displayed when I run a query. In this case, I have a node link diagram with Fretcherman-Reingold. Fretcherman-Reingold is a graph layout algorithm that I discovered using Gephi. It is a wonderful program, but I also like to focus on others such as Cytoscape and WebVal to see how they accomplish things. Fresnel lenses and graph style sheets come from the eispp project. The computing part that applications run on has its own configuration. In this case, it is P2P MPI. Also like the MM80T project. There are also lots of other presently minified configurations for each section in the top row and left column of the EISPP window, e.g. LD browser, production, value network, /*. The best candidate for heterogeneous web scale data I found was Power Aqua. It seems easiest for a user who has no knowledge of the information domain and allows for ontology-based information retrieval. In short, it appears I can get ontologies and information such as triples and documents related to them through a natural language interface. In our thesis, chapters 6 and 7 are of both interest. The documents appear at the top center. The triples displayed as a graph appear at the middle and bottom center, and the individual triples and related ontologies appear on the right. I can also see the triples displayed with the object process methodology, which promises to reduce clutter in the graph. I believe that it's important to see how projects change over time. This is why I show Git for triples, or RNW base, to show how the graph evolves over time. VRM is a core component that acts on projects in the graph, and modernized with DIDs and verifiable credentials, I believe it can be very powerful.
You can select the VRM button for vendor relationship management. According to Wikipedia, it is a concept that was developed in a conversation between Mike Vizard, Gilmore Gang, and Doc Searls, a fellow at Harvard University. A menu comes up with items I hope to fit with Doc Searls' project VRM definition. These principles are: 1. Customers must enter relationships with vendors as independent actors. 2. Customers must be points of integration for their own data. 3. Customers must have control of the data they generate and gather. This means they must be able to share data selectively and voluntarily. 4. Customers must be able to assert their own terms of engagement. 5. Customers must be free to express their demands and intentions outside of any one company's control. When I click the first button titled Bookmark Triples / Save Cache, I get several additional buttons with different options including Save Query Result as RDF File, Save Sparkle Query Input, Save Query Output to Linked Data Platform Container or Collection, and List Saved Items. Clicking Save Query Result as RDF File saves the directed graphs as a collection of triples using the RDF schema. This will save on a local file system or standard web server with no additional complexity. Clicking Save Sparkle Query Input saves the Sparkle syntax that was the input to the Sparkle endpoint in text format. Clicking Save Query to LDP Container or Collection allows one to choose to save the query results as a resource in a linked data platform container, or save the query results in a collection of RDF resources. Clicking List Saved Items gives a list of all things saved previously. Clicking on Federate Graphs brings up a menu that allows one to merge two or more RDF graphs. Here I have two RDF graphs in the File menu, graph_a.rdf and graph_b.rdf. After clicking Load Files, I now have the two graphs loaded. I can select the checkbox, Apply Same As links for equivalent URIs, and click Federate to perform the action in the checkbox. We can check Apply Algorithm in edit:/NLP \* to bring up the Edit Triples panel, which gives us a list of algorithms. Shown here are Christian Bezier et al.'s Active GenLink and Catherine Dentler et al.'s Reasoning by Swarm Intelligence. I can click Start to execute the highlighted algorithm, Active GenLink. Please note that in addition, that Federate can apply to any loaded file, so I could, for example, compare the skills of two people, or how my own skills apply to a particular project by loading the respective graphs. Clicking Load Badge brings up the Loading Badges window. These badges, based on Mozilla's Open Badges, are a record of a particular skill or accomplishment. On the right is a badge assertion in JSON-LD showing a record of a particular accomplishment. This was inspired by Nate Otto's work with JSON-LD for the Badge Alliance. Clicking Load File will load the file as a directed graph by default, and Save File will save any changes made with Edit Triples. Clicking Load Profile / Groups brings up all linked data platform containers, personal profiles in parentheses, such as faux profiles at the parentheses, and collections of resources. Clicking Load File will load the file as a directed graph by default. The button Add to PDS or Personal Data Store will save the file to personal and local storage in parentheses, or perhaps a trusted location in parentheses. The NL Query button will search for additional files locally. Clicking the Access Control button brings up the Access Control menu. On the left side is a menu that is modeled off of the paper by Hollenbach et al. Titled Using RDF Metadata to Enable Access Control on the Social Semantic Web. R, W, and C come from the Access Control ontology. R is for ACL:(read), W is for ACL:(write), and C is for ACL:(control). To the right of R is a column for agent. This lists all agents, each which have permissions set by checkboxes in the R, W, and C columns that have access to the highlighted file on the right. In this case, bchambard.org /fov.rdf #me and example.org /person /fov.rdf #me both have read in parentheses R and write in parentheses W access to the resource example.org /projects/car_project. In addition, bshambot.org /fov.ef also has control access to example.org /projects /car_project, which means that it has the authority to change any access control permissions for any agent through the checkboxes or otherwise by changing the access control file for example.org /projects /car_project. We can also add agents that have access to example.org /projects /car_project or any other item selected in the right pane by clicking the Add Agent button. We can also perform a natural language query to find additional agents to add with the NLQ for Agent button. Clicking Save Changes saves any modifications to the checkboxes and thus access control file for the selected item. On the right, the NL Query button allows more items to be found, ideally locally and on the web. The Add to PDS button allows the saving of a copy of any item found through an NL Query or loaded through the Load File button. The listed items are all items in the PDS. Additional information is also available in Andrei Vlad-Samra's dissertation. Access control can also be based on rules. See, for example, SWRL, swirl, semantic web rule language, and more complex, RIF, rule interchange format. References describing both swirl and RIF, their comparison, as well as their use for access control are provided at the end of the video. Clicking the Transact button allows one to search for and load wallets, use them, and view information pertaining to them. In this case, we have a Bitmark wallet based off of Bitcoin with the URI http:// example.bitmark.com/user/person#persona. For this, we can show related link data for the wallet URI with the Show LD on the right checkbox using the Web Payments Community Group WebCommerce 1.0 specification. With link data, we can show transaction history for a particular wallet. This is all PaySwarm receipts for this wallet. We can also click on an asset in the Display Directed graph to show all the related asset info, parentheses like we saw with the Ripple purchase in another video, in parentheses. We can also purchase the asset, which is at a URI, or click the Negotiate /barter button to see if we can come up with a better price or trade something that we have. This Negotiate /barter button should be integrated with something like Simba so that the seller can be contacted. In addition, the Balance button shows the amount of funds in the wallet. The Find Wallet button shows other wallets to be found that are authorized by the agent using EISPP, and Load Wallet allows a wallet to be loaded. I click the Load Wallet button to load the wallet. I select the :wheel_of_car node. If I click Show Asset Info, I get a JSON-LD representation for the :wheel_of_car asset, like example 1 is section 4.1 in the WebCommerce 1.0 specification. When I press Powder Preferences, I get a menu for Powder or Protocol for Web Description Resources, which is a W3C recommendation. The name of the resource, resources, or regular expression matching the resources are highlighted at the top left of the window. The name of the Powder document referring to this resource, resources, is below on the left, and the contents of the Powder document are on the right. In this case, I have the example.org /projects /car_projects resource selected, which if you remember is really a linked data platform container. Then what I am really referring to is a collection of resources or a single resource in a container, I'm not sure whether it is correct to call example.org/projects/car_projects a resource for powder, although it might be safe to treat it that way. The NL Query button allows me to search for additional resources. The Load File button allows me to load additional resources, or a powder file, perhaps a template that I wish to apply to a given resource. And Save As allows me to save changes to the file if I am authorized to do so. Perhaps it might be useful to provide a functionality like a pull request from Get to the Save As button, so even if I am not authorized, I can submit my changes to someone who is. The Apply to Access Control checkbox applies the Powder document to a grouping of resources described by Powder. I can load a profile template with the Load File button. I can make changes to the template with the Add Tag button. The Add Tag button provides a visual way to edit the profile document. When I click on it, I get a menu which is oriented as a tree, like the XML structure of Powder. I select the Issued tag, which is embedded in the attribution in Powder tags. I can type in the date and time in the Issued tag with computer-assisted completion.
The REA ontology to record contributions and commitments does not show payment activity to my knowledge. This is shown by adding the Ripple and CryptoCoin buttons. Actual payments occur through VRM. EISPP offers Internet of Things functionality. In this case, I have shown an interface to produce items shown in the graph. BotQ, software created by Zach Hogan, allows users to select from multiple 3D printers connected to the Internet to produce their goods. The ISO 15926 standard is used to tie together semantics in the application. ISO 15926 includes an upper ontology and a reference data library to extend it that allows for semantic interoperability amongst applications. The standard was developed for the capital projects industry, which focuses on engineering applications. Focusing on an extensive upper ontology alone may not be sufficient. Dr. David Spivak, in his categorical database talk, speaks about using transformations amongst data rather than focusing on a global source of truth with an upper ontology. He further writes about knowledge representation by using O-logs derived from category theory to rate logic, such as use an OWL, to algebra. RDF used to represent graph-based data that ontologies describe can come from databases through the use of a Graph-Index construction. At this point, further research will need to be done to discover how O-logs, RDF, ontologies, and the use of a Graph-Index construction relate. I expect that a peer-to-peer economy built through EISPP will be a mess of interest. Different projects exist now, like Holochain, which has a sub-project builds upon the REA concepts, and IPFS, which allows for off-ledger storage, which can be used for verifiable credentials. Maintaining integration may be a logistical nightmare, so interoperability amongst the computing and the applications, as well as the related graph, may be achieved by utilizing a distributed virtual machine. Dr. Marco Rodriguez, author of Gremlin, and a participant with the Apache Tinkerpot project, is developing a virtual machine called MMADT, which allows for interchangeable languages, data storage, and data processing. He is also working with Dr. Ryan Wezeneski, who works with Dr. Spivak, to explore the thinking of applied category theory. The goal of MMADT is to have Gremlin and Tinkerpot be a subset, meaning graph-based data amongst other representations can exist. A restful way of accessing graph-based data organized in containers was developed in the Linked Data Platform standard. This standard was implemented in products like Apache Marmota and Solid. A microblogging application called Simba was one of the first demonstrations built upon Solid, but now there are many others. I'm not sure whether any of these technologies say much about how to distribute the underlying data to make it speedily accessible to the user. Of course, CAP theorem will always win. Organizing things I use most, whatever that means, where exposure in EISPP will be a start. Swarm Lambda is interesting. It clusters similar objects and was inspired by swarm behavior in nature. What if I could easily find what I want in a distributed, decentralized space by examining mathematically ants finding my sandwich at a picnic? EISPP allows for the loading of more triples. Triples can also be saved. This graph may be extended in a manner constrained by a selected ontology. This is the edit triples functionality of EISPP. When people think about relations between concepts when describing an idea, they may draw a concept map, but may not think of it in terms of a formal ontology. One needs a way to search for terms from existing ontologies that match what they are looking for. Watson, which was used with PowerAqua, appears to provide a way to do this with its keyword search, at least in part. I believe at the time I suggested a natural language query, possibly PowerAqua, which could be a level of complexity built upon Watson. I also suggested matching nodes to ontologies, with the software giving the best candidates before refinement. It seems I implied I can manually apply a property to one or more edges, or apply best properties by algorithm and selected ontologies to all edges. I did not discuss restrictions on the applicability of the operations placed by the logic of the ontologies. Sometimes when querying information described by an ontology, the user has no idea what the ontology structure is. Enrico Franconi et al. Described using the structure of the ontology to query in their paper an intelligent query interface based on ontology navigation. They call their refinement of constraints intentional navigation. They give 4 operations: add, substitute, delete, and weaken. In my animations, I replicated their process using my own ontology. This could be useful once data is available by loading or through a query. An intelligent Sparkle endpoint was conceived for EISPP. It can start with a graph pattern resulting from the power-accurate query. Elements of the query can be converted to wildcards or be made specific to elements from the power-accurate results. I did not mention it, but I suppose data loaded into EISPP can also be queried in the same way. I believe I later saw an example of an intelligent Sparkle endpoint in the Apache Marmota project. This Sparkle endpoint should also function as a dumb Sparkle endpoint. That is, typing in a query with no assistance. To explore the data by following predicate links among triples, it would be useful to have a linked data browser. This could be like Pinfire or LoadLive. In addition, I decided to highlight linked data containers in pink and minimize their contents by default. Here is my conceptualization of Simile Longwheel, which is an alternative way to view triples.
The following follows what I believe is the same process as Longwheel from the Simile project at MIT. It aims for fauceted browsing. I get here by clicking on the faucet image in the Views panel. I select restrictions on the right panel that describe predicates and objects that should occur in one of the triples displayed in the center pane. I get triples that have any subject and predicates and objects that match at least one restriction. For each matching triple, I have a table. For each table, I also get other related triples that have the same subject. For example, I get all triples that have the : wheel of car as a subject. I can add more restrictions and get even more tables.
Lastly, I thought it would be a useful feature to have an interface to delegate computing resources to applications. I specified the following criteria, if possible: time for completion, cost per completion, geographic distance and location, by some common interest, or other criteria.